Students, next topic is determination of molecular mass, abnormal molar mass. Okay. So you know about colligative properties. 4 are there: R and Vp, then elevation in boiling point, depression in freezing point, and osmotic pressure. So all these colligative properties, they are used to determine the molecular mass of the solute. Okay. For example, for RLVP, relative lowering of vapor pressure, we use Oswald's dynamic method for the determination of molecular mass. Okay. So that is the experimental method. So for RLVP, determination of molecular mass, that is by Oswald's dynamic method. And coming to elevation in boiling point, which is indicated with the delta TB. Okay. So RLVP, relative lowering of vapor pressure, and delta TB is elevation in boiling point. So to determine elevation in boiling point, we use Cottrell's method. Okay. Next, coming to depression in freezing point, we use this symbol delta TF. This is depression in freezing point. So to determine the molecular mass by using this colligative property, generally we use Rast method for the determination of molecular mass of solute. And finally coming to osmotic pressure, which is indicated with the pi. Okay. So osmotic pressure, determination of molecular mass by using osmotic pressure, generally we use Berkeley-Hartley method. Okay. So all these are general experimental methods which are used for the determination of molecular mass. Then colligative properties, they are generally applicable for dilute solutions. Okay. So all these properties applicable for dilute solutions. So solutions which obey Raoult's law, they are generally called as ideal solutions. Okay. So ideal solutions are the solutions which obeys Raoult's law. They are ideal solutions. So Raoult's law is applicable for dilute solutions only. Okay. When concentration of solution increases, solutions deviates from ideal behavior. Okay. So they does not obey the Raoult's law. If concentration of the solution gets increases, deviates from the Raoult's law. Okay. Such type of solutions are called non-ideal solutions. Non-ideal solutions. Okay. So non-ideal solutions are the solutions which does not obey Raoult's law. Okay. So these are the different types of solutions. Ideal solutions obeys the Raoult's law. If there is a change in concentration, concentration gets decreases. Okay. Sorry, concentration gets increases. If we increase the concentration, deviation takes place. Okay. So deviation takes place means they does not obey, those solutions does not obey the Raoult's law. So such type of solutions are non-ideal solutions. Coming to intermolecular forces, in case of ideal solutions, intermolecular forces are negligible. Okay. So in ideal solutions, intermolecular forces are negligible. Intermolecular forces are negligible in ideal solutions. Whereas in non-ideal solutions, intermolecular forces are considerable. Okay? So, intermolecular forces are considerable in non-ideal solutions. Okay? So, generally, colligative properties, they are inversely proportional to molecular mass of the solution. Sorry, molecular mass of the solute. Okay? Each and every colligative property, that is inversely proportional to molecular weight of the solute. So, if a non-ideal solution is there, if two types of reactions takes place in such molecules. For example, if ionization takes place. On ionization, number of particles in the solution increases. When number of particles increases in ionization reactions, colligative property also increases. Why? Because colligative property is directly proportional to number of particles present in the solution. Okay? So, in ionization reaction, as a number of particles or ions increases, colligative property also increases. Okay? When colligative property increases, experimentally proven molecular mass, that is less than that of the true value. Why? Because colligative property is inversely proportional to molecular mass of the solute. As colligative property increases in the dissociation reaction, molecular mass decreases. That's why experimentally calculated molecular mass of the solute, that is less than that of the true value in case of ionization reactions, which are also called as dissociation reactions. If you take association reactions, in association reactions, so in association reactions, many molecules combine together and forms a product. So their number of particles decreases. An association, number of particles decreases. So in association reactions, number of particles or ions decreases. So colligative property decreases. When colligative property decreases, molecular mass is greater than that of the true value. Okay? So in association reactions, as number of particles decreases, colligative property also decreases. With that, molecular mass is greater than true value. Here, in case of ionization reactions, as colligative property increases, molecular mass is less than true value. Why? Because colligative property is inversely proportional to molecular mass. Okay? So, to equalize this, Van Hoff introduced a new factor which is called Van Hoff's factor. Which is indicated with the I.